Good evening, everyone. This is Jishnu from pantechelearning. So I welcome you all for this particular technical plugin Day18 program. This program is conducted by pantechelearning in collaboration with IETE Mumbai. IETE Mumbai provide a vast area for laboratory specifications for electronics and telecommunication department. So they provide a lot of certified courses regarding towards each and every technology functions. So in collaborating with them, we are conducting this particular project awareness webinar, as well as we are also conducting internships on each and every technologies. So today's project is nothing but brain tumor classification using convolution neural network and Matlab. So here today our tool will be the Matlab, and the version whichever I am using it is 2018A. And the complete application is regarding towards a health application or medical field application, just to classify what stage does the brain tumor is affected, like beginning, malignant or abnormal. So in that particular stage we will be able to classify by using convolution neural network, and by using that fuzzy means cluster, spatial fuzzy means cluster, we will be able to segment that particular area where that tumor has been occurred. So this will be our complete project overview. So first let us go for the contents. Today we will be seeing regarding towards this objective of the project, existing system, literature survey, proposed system, block diagram, module explanation, algorithms, and project demo. So first let us start with IEEE paper analysis. So here I have a IEEE paper analysis regarding towards the brain tumor segmentation. So how to calculate that particular tumor functions using this MRI images. But within this particular segmentations or whatever the calculation they are doing on, so there only that technical method is being changed, where we are using convolution neural network as well as spatial fuzzy means cluster. So this kind of technology we are applying over there. But according to this base paper, they are using binary thresholding, and at the same time they are using watershed segmentation to segment that particular area, and then they are applying the ROI section. Okay, so here they are applying, and entire function has been provided. So they are also able to segment some sort of tissues or fat which are providing that particular brain, and they will able to measure the largest area whichever is present over there. The segmentation for that main algorithm whatever they have used is watershed color segmentation. So that particular output you will be able to see here. So this is known as watershed transformation or watershed segmentation. So their complete function will be based on this block diagrams, like watershed output image, then BGR to grayscale, creating in the background, and from that background they are able to apply that binary thresholding, then copy that particular cavity from the background. So their entire progress will be going on in this way, like loading the threshold image, converting the grayscale, from threshold to applying contour. So the contour is nothing but known as the region of interest. So that region of interest only will be mapping over there, and within that mapping they will measure what is the area of tumor that has been affected over there, and from that they will be just shifting over to the biggest contour, and from that particular biggest contour they can obtain the result. So this will be the ratio calculation according to the contour whichever they have been able to apply over there. So our calculation is completely different from this. We are calculating only that brain tumor area. So here they have calculated the brain tumor area as well as the ratio calculation while compared to the brain image. The methodology we are using, it is nothing but the same deep neural network, and from that we are choosing convolutional neural network algorithm and fuzzy means cluster algorithm for applying the contour or segmenting that particular area, especially whatever we are uploading as a basic image. So now let us go towards the objective of this function. The main objective of this particular data is to classify the brain tumor using convolutional neural network, and at the same time we will be able to segment at which part the tumor has been occurred. So this particular existing system we have seen clearly with the help of base paper, and within that it has been explained that they are using watershed segmentation and binary thresholding. By using these two particular area they are applying the contour over there, and from that particular contour applied over area they were able to segregate that classification of ratio and at the same time a tumor area covered. So for that they have applied some of the formulas. So that particular formulas are, so this is for error function. So reference value minus calculated value by reference value into 100, and to find out that particular ratio of the tumor area as well as the brain area. So tumor area divided by brain area into 100 percentage. So based on this particular function only they were able to detect the ratio. So only these two main formulas they have been applied for the calculating the area, and these particular formulas are regarding towards the pixel sections. That is normal functions whenever we apply it in image processing. So the literature survey according to some of the previous papers. So this particular previous paper they were using wavelet transformation, and within this the wavelet function has been failed over there. And at the same time the for another paper they have used classification problem, and it is very difficult to achieve that complete results due to poor texture analysis. So they may have been used the texture analysis in the form of k-means or only binary segmentation. So whenever if you are using only the k-means oriented data, definitely that particular function will be in a low texture quality only. But the same as when we go for the neural networks oriented systems, we will be able to get the result accurate even though the texture or the pixel quality is less while compared to the previous algorithms. So these were among the two papers only I have taken. There are many papers available. So the proposed system whatever we have, it is completely based on the convolutional neural network, which consists of three different layers like pooling, max pooling, and ReLU activation. And here we are also using the fuzzy clustering for tumor detection and structure analysis. So based on that, here I have created a small GUI over there. So here these are our supporting files. Once we start to see that particular project demo, you will get to know. So within this only we are going to do our complete segmentation analysis and prediction. So how this particular function is being going to work, it is none other than regarding towards through this block diagram flow. So here MRI brain image we will be providing as input, and from there the pre-processing, then discrete wavelet transform will be applied over there to reduce that particular sizes of the normal MRI image, and from that we will be applying the GLCM feature. So from that we will be applying to a neural network classifier. The same process we will also be applying for the database images. So from that the feature gets extracted. Here feature extraction is done using GLCM only, gray level co-occurrence matrix. I think before some projects we also applied this particular GLCM feature, and from that while comparing with the database as well as this input system, we will be able to define whether the system is normal or abnormal. And in abnormal we are going with two stages. One is with begin and another one is malignant. So in case if it is begin or under the malignant case, we are applying the fuzzy means cluster, and from that particular fuzzy clustering we are only segmenting or applying that contour area for tumor part, and from that we will be able to validate by what area that particular tumor has been covered. So within this modules, we are going to use three modules. So those three modules are known as the pre-processing, GLCM, and classification. And there is another one module also known as neural network. And regarding that particular neural network, we will be seeing detailedly when we start with the algorithm section. So this pre-processing, it is nothing but whenever we are providing some of the data like MRI. So this MRI scan images are completely different while compared to the another images, because the rest of the images will be based on the pixel clarity, and from that particular pixel clarity we will be directly moving on to the next step of process. And the normal image is contained of two different ways, either with color image known as RGB image, and another one is a gray image. So here it does not depend on upon these two factors, because the scan image whatever we are going to get is completely in different types of scan. So it can be commonly said as CT scan, MRI scan, NMRI scan, and within itself we can say it as multi-slice scan. So each and every scan, it is nothing but to get an inner amount of data through the skull. So it will be passing the rays through the skull, and from that we will be able to obtain the entire visualization, and that particular image only we are able to get it, which is known as magnetic resonance image. So this magnetic resonance image is completely different from the camera images whichever we are collecting. So that way only we have to apply that so for that particular purpose only we are applying that particular pre-processing section. So during this pre-processing section, after just collecting the images, all the noises we will be removing with the help of the filters or that discrete wavelet transform. And at the same time during this pre-processing, some of the filters like median filters only mostly we will be applying. So why we are applying that median filters in the sense, definitely the noise whichever it has occurred in this image, it is known as salt and pepper noise. So the salt and pepper noise commonly set as some of the white pores in a colored image or a normal kind of image. So definitely here we won't be able to see it. through our naked eye through towards the scan image. Why? In the sense this completely will be in the form of grayscale image only, as within the grayscale the gray color and the white portion is completely covering that entire area. It is very difficult to find that particular noise. So to remove that particular noise we will be using median filter, and from that median filter only we will be able to extract the wavelet transform. So from that wavelet transform, therefore that entire process gets completed over there. So these two systems, like applying the filter as well as wavelet transform, both will be done for both input as well as dataset image. Okay, so why? In the sense almost a database and the input system is common. So here these are known as the test images. So just I will open these images, and therefore you will come to know how that particular clarity will be there. So therefore whenever we apply this into that particular system, we can see the difference. Okay, so these are all known as the each and every different image. So we are training all the images, both tumor affected as well as non-affected, contains in the same folder only. So here we have not made any specifications over there. So when we go for that test images, sorry, this was test images and this was train images. Okay, so here you can see for some images like some of the noise whichever you are able to. So to remove that particular noises only, we are here you have asked regarding this from which site to download this test images. So mostly you can move upon with Kaggle oriented sites. So they only provide like image data set and all, that will be the good images. So therefore, to get an effective brain tumor detection and to reduce the impulse noise, we are applying the pre-processing technique over here. So based on this particular pre-processing technique only, we will be able to move towards the further functions, and based on that particular further function only, next we are going with feature extraction. As for all the images, generally whenever we upload any of the images towards the system, the first process is nothing but to convert into the grayscale, and then later on only we will be applying the filters or wavelet transform, like that kind of functions. And from that function, whatever we are going to extract the feature is nothing but the RGB level inside a Greco level matrix. Okay, so that is known as the GLCM. So within that particular gray image, we can obtain some of the different values in the form of matrix by calculating the pixel function. So here we can consider the functions in the form of two variables like I and j, where I stands for the row and j stands for the column. So based on that particular gray level, each and every area gets changed automatically. So whenever we have seen that particular image, that entire image is not covered with gray. Either that particular tumor oriented area is highlighted as that particular more whitish, and the border should be arranged in the form of a gray one, and in between we can see some patterns of the brain that can also be set as a gray color. So this particular area only we will be able to recognize, and we want to just check it whether what is the difference between the test image as well as the database image. So for that purpose, definitely this kind of feature extraction should be applied. So based on that particular glyco occurrence, if that matrix value gets matched over there, then we will be able to see that entire system within that function. Okay, so that matrix value only will be playing a major role So the gray level matrix will be varying from 0 to 255. Like 0 stands in the range of black and 255 stands in the range of white. So in between this particular variation only it is considered as a matrix form conformation, and therefore that particular brain's pattern will be able to record through this Greco level matrix application, and therefore we will be able to combine these two database and test image, and it is very easy to match the features, whether this features is getting matched over there. So therefore whenever we work regarding towards this different kind of gray level function, we are using this CCM. So this CCM only we will be able to determine the size whatever the features we have been extracted, because from a single image itself we are able to see different kinds of functions, right? So just I will explain with that image itself. So here you can see this belongs to one particular size, and this belongs to another kind of size, and this is another one size. So but since it is different kinds of size and all the images comes under the gray level matrix only. So based on this particular kind of functions only we will be completely working it on, and from this working sense we will be able to classify each and every features over there. So that is the main reason we are using this GLCM and CCM to identify each and every size variations of the target. Next. So next we are going moving towards the classification section. So this is the most important module regarding towards it function, because whatever the database we have trained towards a neural network and whatever the functions we have been applied over here, everything will be resulted or monitored only at the period of classification. So here we are training the complete data with the help of convolutional neural network. So it may be considered as a target of dataset 1 or dataset 2 or n number of datasets, whatever we are fixing it over there, and based on that particular parameters whatever it is able to extract, so from that we will be able to match with the trained data as well as the tested data. So for that main thing only we also have used this feature extraction to collect the data, and from that collected data only we are training with the neural network. So we are not training that complete data set in a dumb format. So therefore both the test as well as train will be following the same procedures, and by performing the same procedures the comparison only it will be able to get what kind of tumor it is or what kind of result should be provided over there. So based on this matching of each and every data or matching the number of levels whichever we have been calculated, that numbers only we will be able to say it as a performance analysis. Like if that some of the images may not able to train as easy as possible, or may be able to get the data compared as easy as possible, so in between that particular layers we will be facing some issues, and that particular issue is known as error. So this error rectification, it is very little bit complicated whenever we come with convolutional neural network, but most of them using, while compared to the other neural network, convolution neural network is better. So among this neural networks, convolution neural network as well as backpropagation neural network BPNN, both are good for reducing the errors. So even though that particular it is good in reducing the errors, only some amount it is possible. So for that purpose only we are going with this particular two neural networks, and we will be able to achieve the accuracy of 80 to 85 percentage. In some rare cases it is possible to achieve till 90 percentage or 92 percentage. So based on this particular biases or that classification techniques, we will be applying it over there. So once if it is classified that it is abnormal condition, then the next case it is directly going for the fuzzy clustering. So by applying that particular fuzzy clustering, we will be able to differentiate the shapes that has been occurred in a tumor, and based on that, if any differentiation is applied, we will be applying the ROI over there. So from this ROI, we will be segregating into 4 binary segmented images, which is completely done based on fuzzy clustering. And from that, we will be selecting any one image, and then we will be applying the ROI for the deduction. So under the classification, the final data, whatever we going to receive, it is only 3 data like normal, begin as well as malignant. Only this complete functions only we will be able to classify over here. And now we are coming to the main part of this system, which is known as algorithms. So within this algorithm, we are going to see that convolution neural network. It is an artificial neural network which is completely used in image oriented purpose. So all the image oriented deep learning systems, it definitely works only with the help of convolution neural network. Let it be for training data, testing the data, or matching the two different data, or for face recognition, and at the same time for medical field applications. Everything it can be applied. So this convolution neural network, it completely works based on the multiple layers. So generally when we go for a deep learning or neural network function, that layers are most important part. So within this particular part, we will be having 3 different layers like convolution 1, convolution 2, and the relay activation. And in between this 3 layers, we will be having a small layer which is known as max pooling layer. Okay, so whenever we go for this particular convolution layer, normally the neural network structure will be in the form of neural networks like input layer, hidden layer, and output layer. So through input layer, we will be passing out that complete data, and from that particular input layer, we will be just scattering all that particular images or reducing that particular image, compressing that particular image. Everything will be taken, and these compressions or whatever the scattering what they are applying over there, it will be happened in multiple sections. Okay, so for that, this will be that clear architecture. Like I will be providing this input over there, and within this particular convolution layer, here it gets applied in the form of size as image height, image depth, and image width. So this particular formula only here it will be applying, especially for convolution neural network, whichever we are working with TensorFlow or PyTorch, any other kind of packages. So based on this particular convolution, the starting or that particular image size only, we have to create the first input layer, and that particular input layer will be defaultly taking according to the image, and from that it starts to reduce in the form of multiple sections. For example, if initially you are providing that input in the functions of 28 cross 28 cross 1, then whenever it is going for the next particular max pooling or that consistent convolution layer, the value will be reduced in the form of 24 cross 24. Then here comes with the 12 cross 12, then 4 cross 4, and finally 2 cross 2. So till 2 cross 2 it is possible to reduce it. And within this each and every layer, we can also have another one parameter called as channels. So based on this particular channel function, it is nothing but to analyze the depth of the images. So for each and every layer, it automatically changes according to the number of channels. It depends upon the based on the image classification, whatever we are providing it over there. So here the input layer comes with the first convolution layer, then pooling layer, then again second convolution layer, then again once more pooling layer. and from that pooling layer the complete data gets flattened over there. The flattened in the sense the relay activation. So the relay activation is completely known as the fully connected layer. So from that fully connected layer with the dropout, then only we will be able to see an blur kind of image. It's not a blur, loss of pixels. Many amount of pixels might have been lost over there. So that particular error function only, by using that error only, we will be able to calculate what is the accuracy between trained data as well as tested data. And this is also an important part of the classification. So why we are going for the accuracy in the sense, if the accuracy is in good percentage, then only we will be able to proceed for that, or we will be able to get some belief over there that this neural network is much suitable for this particular application. So it is predicting in a right way. And whereas if you go for a single layer neural networks and all, you will be able to receive that 80 to 86 percentage and all, but there won't be much processing happening over there. And there are also many chances that completely it works only around of 40 to 50 percentage in that way. Okay, so this is known as the CNN architecture. So if you have any doubt till this, you can just post it in the chat box. Then we can move on to the project demo. And guys, if you just like this particular video, please share this to your friends, so they will also get an idea regarding towards this project, how it is being implemented and what are the technologies it has been applied over here, technology, methodology, and the tool that has been currently used. And if those who are new to this particular channel, please subscribe and press the bell button of our channel. Those who have any doubt, you can post it over here. Okay, so now let us go for the project demo. So here I have written the function for application in GUI, graphic user interface, in Matlab. So here for each and every GUI I have defined the functions over here, and for some of the GUI I have called the functions from external option. So for the first function, it is just to display that input image whatever we are selecting from the data set. Then for the second one, it is to resize that particular image into that particular array function. And if that particular image color is around of 3, therefore that particular image alone will be converted from RGB to gray. And here we are applying the median filter to second level median filter. We are applying it over here to remove the salt and pepper noises. Then here we are training all the database which is available within our folder. So therefore all the images will be trained towards the neural network. And finally here we will be classifying it, and for that classification here we are using our transformation sections, and at the same time the other parameters that has been involved in convolution layer. And this particular level is known as the discrete wavelet transform, DWT. So here we have applied for 3 levels, like first level, second level and third level. Sorry, 4 levels are there. So this function regarding towards the Greco matrix, like known as GLCM. So to calculate that particular signal functions, we are using entropy system. And based on that particular entropy, we will be able to get that value of feature extraction. So within that entropy, we are applying both the GLCM as well as the DWT values. So from that particular entropy value, we are getting the feature oriented section. So once the feature is getting matched over there, we will be able to get what kind of data it is. And this particular section is for validating. So for validating, this is that particular formulas whichever we have used. So these formulas and all, we can see it in our previous sections, like parameter evaluation. So here TP stands for abnormality correction, and here FN stands for the normal correction. Then TN stands for normally classified section, and FP stands for normally incorrect classified section. So based on that particular values, whatever we receive, it will be multiplied with that percentage value, and therefore we will be able to get what is the sensitivity, specificity, and by combining all these data, we will be able to get the accuracy as well as the error occurred in training as well as testing the data. So this function, it completely works for segmentation. So the segmentation does only if the tumor is present over there, and for that segmentation only, here we are using the boundary application in order to apply the ROI section. Okay, so now how it is getting trained over there. So here we have that CNN pooling layer. So with the help of this particular pooling layer only, here we are correcting with the number of filters as well as size conversion. So to trim out that particular images, we are using the convolved features in feature trim function. So these are all known as the pooling function, which is known as max pool. So within this architecture, you might have seen it over here. So this area only known as the pooling area. So before that, initially we will be creating a convolution. So this is known as the normal convolution oriented area. So here you can see the function is called with the help of sigmoid formula. So here we are creating the dimension of each and every functions in zeros matrix, like dimension row, dimension of column, filters which and all we are using, and how many number of images. Nothing but known as the channels or depth of the particular image. And here that rows and columns will be calculated or assigned in this way: image dimension row minus filter dimension row plus 1, and the same thing for column. So therefore we will be able to get in the form of square matrix. So the first application will be done for the sigmoid, which is a normal kind of function, and from there the relay activation will be there. This is known as the switch case function. So the switch case will be working regarding towards the non-linear type. So if that particular non-linear type, according to each and every image, automatically it moves over to the all kinds of functions, and among this mostly we will be starting to work only with the help of relay activation at the time of output layer. So next we are going to see the parameters which are all stacked for the CNN. So here that particular same stacking application is done in form of formula by calling the filter dimensions. So this particular filter dimension only we are applying in the convolution layer as well as in pooling layer. And this particular function is for testing the data. So whenever we provide that test data, the same functions will be taking over there, like filter dimension, number of filters, number of images, and pooling dimension. So here you can see loading up this particular data in random order and applying filter for each and every images, and this particular ratio will be standing for how much number of images we are calculating it over there. The same GLCM is being applied, and from the GLCM we are able to calculate each and every features like entropy, energy, and contour, and this will be the shape of the test matrix or the square shape reshaped data over there. So that's it. So now let us run the code. So here I am providing this input image. So the image has been applied with median filter directly. Now I am applying DW2 for it. Now I am processing the database. So training has been completed. Also the classification is also ready. So this is known as the detection stage. So therefore within this particular image whatever I have given, there is no tumor has been identified. Now clear the data, and again I am going to provide another set. The same process that is going on. So the database has been loaded. Therefore it is a beginning stage. 30% has been affected over there. Now let us do segmentation for it. So among this we have to select any of the image for analyzing the result. So normally according to the segmentation we have to choose an appropriate image. So this and all, it looks like a normal kind of brain patterns only. Only this only it is getting different. So I have selected that image, and therefore the area of covered is 14.7084 millimeter square. That is the area that has been covered. So now I am analyzing that complete result. So the accuracy is amount of 60 over there. All the functions are 60. These are all the clustering images using spatial cluster. So I am selecting another image. So this particular stage comes under the malignant, and for this malignant only now I am going to segment it. Yeah, for today's session we have not prepared any of the quiz, so that there is no quiz link available. And the documents we have already uploaded, please kindly check it over there. So here this particular tumor area, whatever we have calculated, it is about of 17 millimeter square. So in this way only we will be able to predict whether brain tumor is present or not by CNN algorithm. So if you guys have any doubt regarding this, you can just post it within the chat box. If you have any queries regarding this particular topic, you can just post it in the chat box. Okay, let us check regarding the documents, whatever the link we have shared. If there is any problem from our side, we will rectify it as soon as possible. No, actually the link whatever we have shared, once you just press it over there, if you have the account in that particular social media, so it will be directly going towards that particular drive in which we have stored our data. Kindly, we are sharing the documents only, but we are not sharing the codes. So regarding your queries as well as the inquiries, you can just follow us on these particular respective numbers. So it depends the numbers of particular region state. And today we are not planning to conduct any quiz. We are planning to conduct, definitely that quiz link will be available in this description box. So I hope you guys don't have any doubt regarding today's session. And these technical issues we will be solving as soon as possible. So thank you to all. We'll be seeing soon with another kind of implementation.